today, and also part of tomorrow too when we do the recursion portion of the workshop. So higher order functions 1. So functions. We're gonna basically talk about kind of like how do we use functions in the same way we use everything else, right? So now when we talk about data types, we're like, well, function is also data type. You can store it in arrays. You can store it as a value for an object. Oh, sorry. Yeah. So with functions, we can store it in an array. We can store it as a value for an object. And we're like, yeah, treat functions like you do anything else, right? And we're going to kind of go with that theme here too. So the question is, why are functions special? The answer is they're not special, right? They are literally just like every other variable that we've seen in JavaScript. And what does that mean? It means we can use them. It means we can pass them back and forth. It means we can return them from other functions. And so the point of today is to show you, hey, functions are not that special, and here's how we use them like we use everything else in JavaScript. We think of functions as being different, but they're really not, because functions in JavaScript are first-class objects, which basically means, one, they're objects, right? Like, and if you think about the way we use an object, it's the same way we can use a function, right? We can pass an object back and forth. We can use it to store values, and we can use them to be stored in different data types. But secondly, is because they're first-class objects, it means they take it basically means they might be treated differently, and they might be treated at a higher priority level in terms of how they're being passed back and forth. But ultimately, we use them the same way we use any other objects. So let's take a look at this. If I have an amazing array, I have happy string. If I push a bunch of strings into the array, I get back. We're missing the commas here, but you can tell it's an array with three strings in it. Similarly, if I have a function and I define it as happy function, and I push the function into the array 3 times, I now have an array of 3 functions. 2 things to notice, right? One is when you print out the function, depending on what kind of editor you're using, you might get this funky thing where it says function and then put it in square brackets. That's more a function. That's more the result of how console logs tend to print out functions. Those square brackets have no relation to an array or bracket notation or anything, right? It's just literally how the syntax looks. Okay, so these are not mini arrays inside of here. They're just a function, and a function, right? Secondly, remember how on Wednesday I said there's a huge distinction with functions between when we create a function versus us running a function. So right now in the code here, is happy function being run anywhere? No, right? At no point do you ever see that function followed by an open and close parentheses, except for obviously when we define it on line 5, right? So this means, once again, happy function is just an object, right? It's just a variable that we're passing back and forth like we do anything else. For all we care about at this point, happy function could be a number or a string, right? We're not invoking it, so we're not really using the function as a function. We're literally treating it as just a variable. So then here, let's talk about how we're going to actually use this function, assuming we actually want to use it, right? So going back to the previous example, let's say we have an array. We have 3 functions inside of it. How do we use it? Well, remember how in the typical for loop, we iterate through it, amazingArray.length, and we say element equals amazingArray index I, right? If this was the string happy, right, what would amazingArray index 0 give me? Happy. It would give me the string happy, right? An element would be the string happy. So if this is a function, and we're going back to the theme of functions are just like everything else in JavaScript, they're just like every other variables in JavaScript. If the first thing is a function, then what would amazing array index 0 be? Function. So what would element be?
Happy function.
It would be the happy function. So then when we want to run this function, we literally just run element, right? Because once again, actually at line 11, we've basically established element is just happy function. Just like how element would be a string if that was an array full of strings, or element would be a number if it was an array of numbers. Element is now a function because this is an array of functions, and because this is a function, we use it the same way we use any other functions, right? Specifically, if we want to invoke it, we just do element open parentheses, close parentheses. Like that's us invoking the function, and when we do, we print out I am happy 3 times because we are going through this array and we are invoking this function one time, this function one time, and this function one time. They just all happen to be the same thing. Any questions? Right. When I talked about for loops, I said one of the biggest things that trip people up a lot is usually like they're confused over like the distinction between the array, the index, and like the element, right? And so in today's workshops, you're going to kind of really get a sense of the array is going to be, what holds it. The index is just a position, but the element is at the end of the day is kind of the ultimate thing that really matters, right? Because the element is what is the value that you're going to be using or reading from going forward. Okay, so that's the array. Passing values into functions, right? So we have a function called logs the type. It takes in a value and then it literally just logs in the type of. So when we feed it in a string, we're gonna get back type of happy string is a string, right? Nothing fancy, nothing new here. But like we said, if functions are just values, variables, however you can call it, if they're just like all the other variables we've seen in JavaScript, it also means we can pass in what? Functions in, like we do any other parameters, right? And so now when I do logs a type and I pass in a function that I've written. So how this code reads is between lines 1 through 13, like nothing's being run. Line 14 is the first time in which we actually run, like execute a function, and we're executing logs a type. We're passing in this happy function, and so after line 14, it goes back to line 6. Value becomes happy function, and on line 7, we're console logging out type of happy function. So the answer we get is it's a function. Right? So once again, are we running happy function at any point on this page? Are we running logs of type at any point on this page?
Yes.
Great. Awesome. That's the distinction, right? Is we're passing happy function back and forth, but we're never running it. We're never invoking it. We're just literally treating it like we would any other variable. And so if we want to actually invoke it, guess what? We actually need to invoke it. So this looks almost the same as the previous page, except now instead of calling a logs a type, we call it calls a function. And if you notice, what this calls a function does is it takes in something called another function, and then we actually run it, right? Here, we see the open and close parentheses. This is the actual point of invocation. So when we get to, we skip, not skip, but we go through lines 1 through 10, nothing happens yet. On line 11, we actually run calls a function. We go back to line 3. It's like, oh, what am I taking in? I'm taking in happy function. Okay, great. So after line 3, this variable, another function, becomes happy function. So when we invoke another function, we're basically invoking happy function. Cool? Yeah. Yes? Awesome, right? So once again, at the end of the day, functions, we are treating them like we would any other variable, right? If this was an array, we would not push the array and we expected to change the original array. It's a function, so we can run it like we would as if we had the function, kind of in our hands, metaphorically speaking. Calls with name, same idea. We get to line 13, we actually see calls with name, right? Here we have something called, the first argument is a string called Sadie, then we call says hi, right? And what the says hi function does is it actually takes in a name and says hi name, right? Except we can't just jump straight from here to there, right? We got to go through this calls with name first. So calls with name takes in 2 arguments, name, which is Sadie, and then callback, which is says hi. And then if you notice on line 10, what we're actually doing is we're saying, hey, let's now invoke callback with this name as the first argument. So only after line 10 runs do we then go to says hi, and we invoke and we pass in Sadie as a name, and then we console log out hi Sadie. We did a problem, actually a more complex version of this problem. What was it, like on Tuesday or Wednesday? Was the calls with all, where we give you an object where all the values are functions, and your goal is to invoke every single function. Every single function was a given argument, and you store all the values and pass it back in an array. Same idea here, right? It's the idea that like, hey, once I pass in a function as a variable, I can then just treat it as if I had a function, and I can invoke it. And when I do that, I can invoke it like I would any other function, but I can pass it in different arguments. Yes, this slide makes sense? Makes you uncomfortable? guess also, yeah. Any questions though? Right? If you get stuck, like go through it line by line, like draw the arrows if you have to. Like just once again, this is a very linear process. Each line calls something else different. Okay. And then this is like every slide from here on out is going to be me saying the same thing over and over again, right? It's just different applications of the same idea here. Here, instead of just calling functions, we actually see our old friend return. So on line 9, line 9 is the first time we actually invoke anything. We have the calls with hello function. It takes something called func. And in this case, we're passing in add world as func. So on line 6, func is going to be add world, and hello is going to be string, right? So on line 6, we're invoking func hello. When we invoke func hello, it says, okay, I'm going to make a string called hello world, and I'm going to return it, right? In JavaScript, what do we return? What do we return things to?
Functions.
Functions return things, but what do we return things to?
Nothing.
Yeah. It's kind of like the analogy with like your boss and handing in work. Like you hand your work into usually whoever asked you to do in the first place, right? So in this case, we have this hello world string. Who are we returning it to? Well, we're returning it to whoever called us, right? And line 6 was where we were called, right? So we return hello world to line 6, and then we say, all right, great, return that. And so the question becomes, where do we return hello world to from there? It's like, well, we return it to whoever called us, right? Whoever asked us to get this value in the first place, and who calls with hello? Line 9, right? So this becomes, okay, great, you calls with hello, and the answer is hello world. So let's capture that in the variable called result, and then when we console log out the result, we get hello world, right? So return statements, like so far in the problems that we've done in the workshops, we've kind of taken for granted that when we return, it kind of magically happens. But if you really think about it, like how do your tests work? Your test calls your function with the inputs. It captures the value you give back somewhere, right? And it compares that value to whatever it is. So this entire time, your function has been returning the value to whoever called it. In this case, it was a test, right? So we've been, in your functions, wherever you've written a return, it's been returning the value to the test. And the test does a comparison, say, oh, great, your answer is 6. The answer I want is 6. You're good. This is the same idea, except now when we trace through this, you just want to be very careful that, okay, this is add world is returning it to who? Add world is returning it to line 6, right? Because func is add world, and we're actually calling add world here. We don't return it from here to here directly. We return it from here to here, and then this returns it from here to here, right? It's like if the CEO of your company asks your manager to do a project, and your manager asks you to do a project, you don't necessarily just give it to your CEO directly. You give it back to your manager decides, oh, let me give it to the CEO, right? Same idea. Very logical process. You return things to whoever called you or whoever asked you to do it in the first place. Any questions? No, it's getting hot in here, so I'm going to turn the AC as soon as we finish this lecture. Cool. All right. Yeah, I mean, the rest of these are, once again, just like very simple applications. Here, what we're doing is we define a bunch of variables, but on line 13 is really when we execute our code, if you will. We're passing in something called group to say to all. Group is an array with 4 names. Say to all is a function. We're passing in group, and then we're passing in says hello with name. So this is a function. So after line 13, as we go back to line 1, names is this array of 4 names. Says with name, func is say hello with name. And all we're doing is we're iterating through the array, and we're passing in each element in the array into the say with name func. And we're invoking say with name, which basically means we're invoking say hello with name. So when we run this, line 13 takes us to line 1, line 1 takes us to line 2. We're now iterating through Jane, Jill, Pip, and Mike. And for every single one of those elements, we're invoking say with name func, which is basically says hello with name. And which we pass in Jane here, we invoke it. We pass in Jill here, we invoke it, Pip, and Mike as well. And that's why over here, and after we invoke it, we console log out like the message, hello blank. That's why after we run this loop, we have hello Jane, Jill, Pip, and Mike. Right, so once again, very logically just invoking things, right? Like this is a part of the code where it really, really helps if you're getting confused is to step through it line by line, right? Like we're using a for loop, we're using a function invocation. There's no new concepts here. It's just being more familiar and comfortable with using things that we've already seen. So yep.
So say with name func right there when it calls names with the index of it.
Yep.
If I were to just replace say with names with just names again, and then call it with that, it would return false.
Sorry, you replace what with what?
Oh, say with name func.
Yep.
Just names itself, and then call it.
You mean replace this part with just names?
Yeah.
So say with names func if you replace with names. So names is the first argument.
Yeah.
Say with func name is the second argument, right? So this is a function and this is an array. If I replace this with names, I'm replacing this with an array.
Okay.
And I can't invoke an array. So it would probably break. Yeah, it would give you an error saying names is not a function. Okay. Oh yeah, this is more of a syntax thing. No new concepts. Before we created a function called let say with names or function say with name equals basically. Here, if you notice, we can also just write the name of the function in directly. Notice how we don't need to give it a name. This is called an anonymous function. It's called an anonymous function because it's a function. It just has no name. So basically, if we create it and we don't store it anywhere, then we kind of permanently lose access to it after we create it. So that's why it's called anonymous. And it's useful when you're trying to write functions that are only going to be used once in a certain context. But yeah, like performance and conceptually, nothing different. It's just here instead of writing giving this function a name elsewhere and then passing the name, you also can just write the function directly here.
Is that slide actually calling anything? No, right?
Yeah, it is.
Where?
Say to all. We're invoking that.
Oh.
So when we invoke say to all, we actually also invoke say with name func. Say with name func is now this anonymous function. So we're invoking it up here.
And then adding code to it?
And then passing in the names.
I'm just confused by the curly braces on 11 to 13.
Well, this is part of the function definition, right?
Yeah, so if you're passing same names with
This is literally the same as the previous side here. Except I'll notice here we have this thing. We took this, lines 9 through 11, and rather than capturing it as a variable called say hello with name, we just literally pasted it here instead. It's the same idea as if I had a function.
Oh, okay. Is that commonly used?
Yeah, it's commonly used in certain contexts. Sometimes you have a function that you're only writing for like a very specific limited purpose, and so you don't need to create it. You don't need to store in a variable. So like let's say I have it's a difference between saying like let x equals 6 plus 7, and then console logging out x, versus just saying console.log out 6 plus 7. Right? Before we were storing the function as a thing and we passed in that thing. Now we're just passing in the function directly. So here we're storing it in this variable called say hello with a name, and we're passing it in on line 13. Here we're saying, hey, let's just write the variable into the passing it into directly, right? On line 11, that anonymous function, we're not running it just yet, right? It's actually being run on line 5. Because after we pass in this says to all, after line 3, says with name func becomes that anonymous function. Right? So when we execute say with name func on line 5 there, we are actually invoking that anonymous function. Ever follow that? Sure. So this function here, between lines 11 through 13, we're creating it on line 11 and passing it in as an argument to the say to all function here, right? So say to all, when we go back up to line 3, the first argument is names, which is what? The second argument is say with name func, which is what? That function we just created, right? The anonymous function, right? So when we invoke say with name func here on line 5, what are we really invoking? We're invoking the anonymous function that we created on lines 11 through 13, right? Literally, functionally, or not functionally, conceptually, note, like there's no difference between this and the previous slide. We just happen to say, let's just bypass storing an extra variable. Let's just like feed it in directly. And then, yeah, just more and more examples of these problems here. I probably won't go through like the next few because they're all going to be very similar. Here, feel free to take a look at it kind of on your own time, but essentially we pass in a number, an operation, and another number, right? Calc on line 9 there, and we just basically run that function with the inputs that we gave it. So this is just more of like a, as we step through it line by line, like, can you explain, very, very clearly at every single step what's happening, right? And then the last thing we'll talk about is this idea of a for each loop. A for each loop is a shortcut. It is something that if you never ever want to use ever, you don't have to. But it does make your life a little bit easier in some ways. For each is a method, and methods are tied to objects. So what object is tied to? This is tied to an array. So every array that we've ever written has a built-in for each method. What the for each method does is it accepts as this argument a function. So here, like if you look at the code on this page, bridges is our array, right? And log uppercase is our function. What does log uppercase do? It takes in a string, okay? And so when we do bridges.forEach, as the argument, what we pass into it is this function called log uppercase. And what for each does on your behalf is it will go through the entire array and it will run that function for every single element in your array. So a few questions here, right? The first one is, well, what if I want to skip certain elements? Or what if I only run it for every other element? The answer is don't use for each, right? For each is designed so that you are running it on every single element. The second question, and the more pertinent one here is, well, hey, when I invoke that function, on line 3 there, it says log uppercase takes in a string, right? And nowhere in the code do I ever see log uppercase actually being invoked, right? We never see log uppercase with an open and closed parentheses after it. And the reason for that is because this is what for each is doing behind the scenes. For each is invoking the function for you, right? So then the next logical question from that would be, okay, so in this case, my log uppercase function takes in a string. How does for each know what to pass into it when it does invoke it? And this is the last part of the magic of for each is when for each invokes a function for you, it is always going to pass in for you the same arguments in the same order. And so because of that, you need to write your function. If you're planning to use for each, it's up to you to write your function in a way that's compatible with for each. Because for each is never going to change itself to be compatible with your code. And what the for each is always going to do is it's going to invoke your function for every element in the array, and for every single time it invokes it, it's going to pass into the function the element as the first argument, the index as the second argument, and the array itself as the third argument. Notice how the log uppercase function, it only takes in a string, right? In our case, it only takes in the element. So even though for each is passing in 2 other arguments, the function kind of ignores it, which is totally fine, right? Like if a function is designed to take in 3 things and you give it 20 things, it will just say, give me the first 3, I'll ignore the next 17, right? Same here. This function is designed to take in 1 thing, so when we give it the element, then the index, then the array, it will say, oh great, just give me the first thing, which is the element. And then it kind of does what it needs to do, and it goes on to the next iteration. Yeah, so for each is a shortcut. It basically runs a function for every single element in your array, but it's up to you as a programmer to understand how for each works if you want to use it, because for each is going to do the same thing over and over again, without regard for what you want it to do. We can also really easily write for each with a normal for loop. It's just a little bit more writing. And so for each, once again, it's a tool, it's a shortcut. If you want to use it, practice it. If you don't want to use it, don't. Right, Osiris?
Can we take a lunch soon?
I'm sorry, is this working?
Nah, you're not a big deal. Jake?
Wait, so this is just like doing the classic like nest. Like, could you actually use this to get elements inside arrays?
No.
No, just elements inside of a single array.
Yep. Because so let's write this kind of like so let's write this yeah. Well, no. Here, so let's just write this like if we had to write this in long form, as in we would write it from scratch. Let's make sure we know how it looks, right? So this is called like the for each method, and then this we'll call like the for loop method, right? And it's literally just for let I equals 0, I is less than bridges dot length I plus plus, and then here we're saying log uppercase, and we're passing in bridges index I, passing in I, we're passing in bridges, right? So these line 7 is basically a shorthand for line 10 through 12. The only limitation is when a for loop, we can change any little things. We can change the index, we can change the code block, and change all these things. And for each doesn't let you do that. For each says this is what I'm going to do every single time. So you better, if you want to use this, make sure you better fit that criteria. Yeah, Josh.
Why did you do comma I, comma bridges?
Because it passes in 3 arguments. It passes in the first argument, which is the element. Then it passes in the index as a second argument. And then it passes in the array, which is bridges, as a third argument.
What does?
For each.
So could you run the for loop without the I and the bridges so we could see like what would happen?
I could even run it with the I and bridges, and the same thing will happen. All right, so
The reason you have the I and the bridges there is to duplicate exactly what for each is doing. But were you to just be uppercasing the 3 bridges, you wouldn't need I and bridges.
yeah. But the point of this is to show you that for each is going to feed those things to you, and you don't really have an option to say I don't want it. You can just choose not to use it.
Right.
And the reason why that's important is because if you only want the index, then you need to customize your function to take in 2 arguments, and you ignore the first one. Right? You can't tell for each, hey, only give me the index today. It's like, no, I'm going to give you these 3 things in this order every single time. Doesn't matter what you want. Like, this is what you're going to get.
What's the second argument?
I, which is the index, and then the third argument is bridges. For each MDN. If you ever get lost or get confused, and it's very totally normal, all of this is also very well documented too in almost all documentation. Yeah. Callback function to execute, and the function will take in 3 arguments: the current value, then the index, then the array. Right? Cool. I believe that's the last slide, or at least passive review slide. Yeah. So now so this example, we basically have a new function we're passing this for each loop, except now this function takes in 2 things. Takes in string and IDX, which by definition has to be the element and then the index, right? Because that's what for each is going to call it with. It's going to call it with string as a first argument, index as a second argument. We do that, and that's pretty much it.
What happens if you put in an index?
I'm sorry?
So for each takes in an index.
For each takes in a function. The function takes in whatever you want it to take in.
So what's spitting out I in bridges?
What's spitting out I in
On the previous
bridges?
slide. Like I saw below that.
Below that?
Or was it a different slide where you had the for loop?
Oh, that was
Oh, yeah. So log to uppercase that function.
yep. That's
only
constant.
Accepts a string.
Yep. It only accepts in 1 argument.
Yeah. So then why did you write it as accepting 3?
I didn't. What I'm saying is for each,
Yeah.
the for each. So these two are supposed to be synonymous, right? For each is going to call it with three things.
And what's the third thing?
The array itself.
Oh, because that's how for each works.
Yep.
Oh, okay. I understand.
So this is what for each doesn't do. It does. You can't change any of this. This is how for each works. If you want to use for each, you have to like kind of make peace with these rules,
Yeah.
right, Ariana?
Right.
Yep. Cool. Any other questions? All right. Sounds good. Yeah, that review took much longer than I thought it would on the